I was once reading a news article. I think it was Tech Review, and I'm going to mess up the statistic, but I remember reading an article that said something like 1/3 of all programmers are self-taught. I may have the number 1/3 wrong, maybe it was 2/3. But when I read that article, I thought this doesn't make sense. Everyone is self-taught, so because you teach yourself. I don't teach people.
Right.
I just
That's well put.
In this video, I'll be giving you a step-by-step guide on how to become a robotics software engineer. I'll be giving you 19 steps to become a self-taught robotics software engineer, and I'll be giving you specific set of resources that you can follow to really make that transition. And these resources include YouTube videos, courses, lectures, tutorials, and any other resource that might really help you learn robotics. So let's get started. Welcome to Learn Robotics in AI, and let's talk about how to become a self-taught robotics software engineer. So before I proceed with giving you the exact steps to make that transition, I want to make sure that you have the right background, and I want to tell you what are the prerequisites, if any, in order to really make that transition and how you can actually make the most out of this video. So first of all, this video is targeted towards people who have a certain level of an engineering background. If you're involved with mechanical engineering, electronics engineering, or software engineering, it might be that you are pursuing your bachelor's or master's in any of these domains, or another engineering domain such as civil engineering, or you are a working professional in any of these engineering domains and you want to make a transition to robotics software engineering, then this is the exact video that you should follow. And probably you don't have the option to go for a master's, and that the reasons could be manifold. It could be that you do not have the financial means to pursue a master's, or you have other constraints related to familial or societal or even location related constraints, and you cannot afford to pursue a master's for any of these reasons. So this video would essentially help you transition to robotic software engineering without any professional master's degree. So let's have a look at all of the 19 steps now. Step number one is to define your core motivation. Before you even start learning robotics, you should spend at least a few hours really getting an insane level of clarity on what your core reasons for pursuing robotics are. Do you want to pursue robotics, machine learning, or computer vision because it is trendy and everyone else is doing it? Or do you want to pursue robotics because it has a lot of career opportunities in the future and you want to earn a lot of money? Do you want to pursue robotics because you're genuinely passionate about robotics and you want to learn how to build robots, how to program robots, and how to integrate and include artificial intelligence algorithms to make robots more autonomous? What is your core motivation? The primary reason why we want to start with asking this question is because robotics is hard. It is interdisciplinary. It involves a lot of different subdomains and different engineering fields. And if you are not clear on your why, you would probably lose motivation and give up along the journey of learning robotics. So if you're solving a problem, if you're doing a project and solving a problem, and you see that, hey, I don't know how to solve it, and your motivations are not really clear, then you would not really stick with the project. You would probably drop out, because robotics requires a lot of things, and especially robotic software engineering requires you to learn a lot of different software frameworks, programming languages, and tools that would essentially make you employable in the industry. So make sure that your reasons are correct. And I really want to drill home this idea of having your core motivations clear. And in order to do that, I want to tell you a story of someone I know who actually decided to pursue a master's in robotics. He was already from an engineering background. He worked as an engineer in a company before, and he now wanted to go for robotics. And his primary reasons were not that he was super passionate about robotics or that he did a few projects and he wanted to explore that more. His primary reasons were that robotics and AI are fields that would essentially guarantee career opportunities in the future. There would be plenty of jobs in these fields, and so it makes sense to really keep my future secure. So that's why I want to pursue robotics. So this was his primary reason. And the sad thing that happened was that he dropped out after the first semester, and that is because he started because of wrong motivations. He started because he had some expectations that, hey, I'm already from an engineering background, robotics cannot be that hard, and I want to have more career opportunities, I want to earn more money, I want to have a safe career path where I can have enough money in the future. So, and then when he started learning robotics in the first semester itself, there was control systems, there was kinematics and dynamics, there was machine learning, computer vision, a lot of different domains in the first semester. So he said, yeah, maybe that's not for me. It's a lot of theoretical knowledge that I need to accumulate, and I don't think I'm ready for that. So he dropped out, but you can imagine the time, energy, and effort that he wasted. Now, application for masters itself takes a lot of time. He probably started preparing 6 months or even more before he started his master. So the 6 months that, and then 6 months of the semester were wasted. So you don't want to start pursuing a field and then realize, hey, it's not for me. So make sure that your motivations are clear. And I know this cannot be that simple to answer, and in order to help you really realistically answer this question, I urge you to watch the following videos. Watch my video titled Top Reasons to Study Robotics. And then the other video is Do Not Study Robotics for These Reasons. So this video includes the wrong reasons for pursuing robotics or artificial intelligence, data science, or machine learning. If you want to pursue AI, ML, robotics because everyone else is doing it and so you don't want to get left behind, that's a wrong reason. Again, watch these videos, spend some time really identifying and defining your core reasons, and only then move to the next step. What is step number two? The step number two is essentially to build a strong mathematics foundation. Now, this might be disheartening for some of you who would have expected that robotics probably doesn't require a lot of mathematics and I can just do some projects and build some programming skills and I can work as a robotic software engineer. Well, you do need a strong mathematics foundation, and if you are from an engineering background, the good news is that you probably have a good mathematics foundation already. If you prepared for some competitive exams in your 12th standard or 11th standard and so on, you have a certain mathematics background. But if you did your bachelor's or you're currently doing your bachelor's in an engineering domain, you probably have the prerequisite mathematics skills needed for robotics. You probably know calculus, linear algebra, statistics, probability, matrices, differential equations, and so on. So you probably do not need to spend a lot of time building a strong mathematics foundation if you have that already. But even if you do not have that mathematics foundation, I would urge you to really spend some time building that strong mathematics foundation. And I'll not just ask you to do that, figure it out all by yourself. I have some resources that I can really direct you to. So one such resource is Rob 501 Mathematics for Robotics. This is a YouTube playlist that you can really follow, and this is designed specifically for robotics. It covers all of the fundamental concepts that you might need for robotics. So go ahead and follow this. If you don't if you don't resonate with this resource, go ahead and look at other courses by the top universities and essentially follow any mathematics lecture series and try to solve some problems by yourself and get familiar with the fundamentals of maths. Let's move on to the next step. What is step number 3? Step number 3 is another disheartening fact for you, is that if you want to work in robotic software engineering, you need to stop using Windows for programming and you need to switch to Ubuntu. Now there's multiple reasons for that, and you can also get by just being with Windows, just working with Windows, but most companies use Ubuntu operating system. And in fact, ROS was developed on top of Ubuntu, and support for ROS on Ubuntu is much better as compared to that on Windows or Mac OS. So these are a few reasons. And also, if you look at the job descriptions for most of the robotic software engineering profiles, they explicitly state that we want someone with Linux background, someone who has experience working with Linux. So this is the reason to switch to Ubuntu operating system, and you need to switch to Ubuntu sooner or later. So I've given you the reasons. Now, how would you actually switch to Ubuntu? I'll again give you a resource that you can follow. I have explicitly given you one resource for each step so that it's not super confusing, but you can easily look up alternative resources similar to the resource that I shared. Now, I want to make a point here. The things that I have talked about so far, here you need to identify your core motivations. I've said that robotics can be hard, it's interdisciplinary, and it can be challenging, and you need to have your whys clear. I've talked about the fact that you have to have a strong mathematics background. I've talked about that the fact that you need to switch to Ubuntu. Now, all of these things can be demotivating for you, but it shouldn't be, because all of these steps do not really require that much effort. Like identifying and defining your why for robotics, it would take a few hours maximum. You can take a couple of days if you really want to think about it, if you're making some serious career transitions, but essentially it doesn't take that much time. Now, building a strong mathematics foundation, you probably have that already, but even if you don't, you can take a few weeks, a month or 2 months, and really build that mathematics foundation. So all of these things are doable. So my goal with this video is not to dishearten you or discourage you from pursuing robotics. In fact, it's the opposite, to give you a step-by-step guide to really pursue robotics all by yourself. Okay, let's go ahead. So here's a resource, here's a crash course on Linux, specifically dealing with Ubuntu, that you can follow, and that's a good resource that would allow you to really get familiar with basic command line uh, commands and Linux tools and the functionalities that are involved there. Okay, moving on to the next step. Step number 4 is to install Visual Studio Code. If you have been programming a little bit, you probably are familiar with some IDs. You probably use Visual Studio Code or PyCharm, but if you don't, it's not a big deal. Install Visual Studio Code, and that would just essentially make it easier for you to program tasks. You can even program on text editors, although that is not really recommended. And there's a lot of different kinds of IDEs that you can use, integrated development environments for programming. They make the overall programming experience easier. So Visual Studio Code is what I recommend because it is easier to start with and it doesn't have a lot of confusing toolbars to begin with. PyCharm is something that you would eventually switch to. It has a lot more functionality, but to begin with, stick with Visual Studio Code. A lot of professionals also use that. So this is something that you can reliably work with. Then there's Vim and Emacs and other more advanced and more customizable IDEs, but you do not need to worry about that. So stick with Visual Studio Code, and here's you can find official documentation on how to install Visual Studio Code on Linux, and you'd be able to figure out um, what are the relevant resources. So here is All of these different resources have been compiled in the form of this article that I've opened on my website, learnroboticsandai.com. And you can actually go ahead and look at some of the resources that I've shared there. So Visual Studio Code on Linux. If you for some reason still chose to go with Windows, to stick with Windows, you can install Visual Studio Code on Windows, but uh, you need to understand that ROS is easier to work with on Linux. So make sure to switch to Ubuntu, and this is a step-by-step guide. One of the later steps is also to work with ROS and other robotics related um, tools. And if you're still stuck on Windows, then it would probably make the subsequent steps slightly more complicated, although that's also doable. Okay, Visual Studio Code has been installed. What is step number 5? Is to create a Conda environment. So this is something that you also need to know. You can work with creating Python virtual environments as well. That is one alternative. But Conda is also used a lot in the industry. It's essentially if you're working on a project and it has a certain number of dependencies, for example, it uses a certain version of NumPy, a certain version of Python, a certain version of PyTorch or TensorFlow, a certain uh, Gazebo or Mujoko or PyBullet version, then you need to create a separate environment for yourself that would be suitable for that particular project. And this can be accomplished by means of Conda. So Conda allows you to create several different environments for different projects, and you can use it for different purposes. So install Conda. If you don't know what Conda is, and if you don't know if it would be useful, just trust the steps that I'm giving you and install Conda. You would need it in the future. Getting started with Conda, here is a resource, the official resource that you can follow, and this would essentially give you enough understanding of what Conda is. You just need to install and get used to it, get used to creating a Conda environment. All right, so you've already accomplished a lot of things now. You have your IDE ready, you have your Conda environment ready. Now you're ready to learn Git. Git is used for version control. It's a version control tool, and this is something that all software engineering companies use, either Git or some other version control tool such as Tortoise, Git, or some other version control framework that is used. But Git is the most widely used. And if you work in a robotics software engineering company, the likelihood is high that you would work with Git, GitLab, or GitHub. And make sure that you familiarize yourself with Git. I wouldn't go into too much details of on what Git is. I would redirect you to the video that I created as part of the Learn Robotics and AI meetups that we used to conduct several months ago. And here, this video consists of everything you need to get started with Git. It is not a structured video. Uh, it was part of a meetup, so you would see me discussing Git and how to install Git, the basic Git commands with a lot of people who joined the meetup. But this would essentially give you all the basic Git commands that you would need to know, and you would also be able to find a Git cheat sheet that would have all of the basic Git commands in one place. So make sure to keep that handy whenever you start working with Git. Okay, what is the next step now? Step number 7 is to learn Python. So far we have just built a foundation. We have installed Ubuntu. We have defined our why. Why do we want to learn robotics? We have installed an IDE, Visual Studio Code. We have our Git ready. We have a Conda environment ready. So all of these basic foundations have been set. We are in a programming environment now. We have the Visual Studio Code open on our Ubuntu operating system, and we want to now learn Python. If you have no programming experience, I urge you to start with Python. Python and C++ are both used in robotic software engineering for low-level control and working with hardware systems, C++ are more widely used. But again, machine learning and computer vision are also an integral part of robotics. So you also need to have Python experience. But as a beginner, if you have no programming experience, stick with Python. That would make the overall programming experience easier for you, and you wouldn't get overwhelmed by programming. So once you're familiar with programming and you can take up this Python crash, yeah, so we were on Python. So now the next step is learn the basics of C++. So as I said, I have this resource already on the website learnroboticsandai.com, and if you have a certain level of Python experience, you can go ahead and start learning some C++, and this is the best resource that I found on C++. It's also on the website that I shared on the blog article, and this is specifically coming from the Computer Vision uh, Institute or Laboratory by Professor Cyril Starkness in the University of Bonn in Germany. And this is this lab specifically works with robotics, and they have created a set of modern C++ lectures and tutorials which are very good. And these are some things, these are some tutorials or lectures that I highly recommend you learn, especially if you have a certain level of Python or programming background already. Or you can take up any other C++ tutorial. So again, feel free to use alternative resources, but make sure to follow these steps in a sequential manner. Okay, Python, C++. And step number 9 now. Learn TensorFlow. Now, do you need to learn machine learning for robotic software engineering positions? Well, it depends on what specific role you are targeting. So if you are probably working with perception or navigation, you would be working with machine learning in one way, shape, or form. If you're working with controls, you may or may not require machine learning, but it still helps to have a basic foundational understanding of machine learning. And TensorFlow is one framework that is easy to start with for machine learning, and it is also very widely used for in the industry. If you're going for research, PyTorch is probably more widely used, and it has more features. It's more advanced, and it's more suitable for research applications. But for industry, stick with TensorFlow. And also, machine learning is going to be used more and more in every industry, and especially in robotics. So make sure to learn TensorFlow, and you can do that by this really wonderful resource by free code camp, I think, called TensorFlow 2.0 crash course. So this resource should be all you need to know to learn TensorFlow, or you can actually even take up a course on the website deeplearning.ai by Andrew Yang. There's a lot of really nice resources, or on Coursera. Just make sure to stick with the resource and learn TensorFlow. All right, so we've already come a long way now. We have learned Python, C++, we have learned TensorFlow, we have the Git environment ready, Conda environment ready. All of these basic things have been taken care of. So what is the next step now? Step number 10 is to learn OpenCV. Now you probably need to learn some computer vision if you want to work in robotics navigation, if you want to work with mapping and localization environments. You'd probably be working with computer vision, and OpenCV is the standard library that is used by most industries for computer vision. And this is something that you should definitely focus on giving some time to really learning and mastering OpenCV. And this is another free code camp resource, OpenCV and Python. And another resource is Learn OpenCV in C++ in 4 hours by the channel Murtaza's Workshop. This is another good resource. I actually have a playlist called OpenCV Crash Course. I haven't linked that resource in this tutorial because that is not complete. I just created chapter 1. So that was basically an experimental chapter series with me explaining OpenCV by the means of a storyline of a mysterious map. So the mystery of the enchanted map is, I think, how I've labeled the story or named the story. And that is just a very fancy and interesting way to learn OpenCV. And I might extend that and create further chapters because it's a story and I already have the storyline prepared. And what are the AI generated tools and AI generated avatars I would be using and I have used currently. um, those are all the things that I have prepared, but didn't get the time to really continue with subsequent chapters. If this is something that you would find interesting, make sure to let me know. And you can have a look at that resource on the website learnroboticsandai.com. The Jupyter notebook for chapter 1 is also available for free there, and all the tutorials in the form of videos are available on YouTube in a playlist called OpenCV Crash Course. So make sure to check that out, and also make sure to let me know by joining the waiting list for the course on the website learnroboticsandai.com. And if there's enough people who are interested, I would continue with the subsequent chapters. Or you can follow these meanwhile you can follow these two resources that are actually very good to begin with. Okay, machine learning done, computer vision done. Now you have to learn some robotic specific tools. Simulation is essentially a very key component in robotics. For robotic software engineering roles, there's a variety of different interesting and useful simulation platforms that are coming up and that are being used actively in robotics. Isaac Sim, PyBullet, Mujoko, all of these are really nice uh, simulators that are used, but the most widely used simulator is Gazebo. And because it is uh, very well suited for ROS. It is very compatible. It is very compatible with ROS, and that makes the overall process of building robotic systems in simulation environment very easy. So make sure to learn Gazebo, and you can follow this nice tutorial on Gazebo. Essentially, there's an unlimited number of tutorials and tutorial series on Gazebo. You would be able to find it. It's very easy to learn, so it shouldn't be that complicated. Once you have learned Gazebo, now comes the time to learn your favorite tool, which is ROS or ROS2. Now, should you start with ROS or should you learn ROS2? If you've been following my videos, I have talked about the fact that if you can, just start with ROS2. A lot of companies still use ROS, but they would eventually transition to ROS2. And I have mentioned multiple reasons for why you should install ROS2 and which version of ROS2 you should be working with in my video titled The Most Comprehensive List of ROS2 Resources for Beginners, and also top 10 ROS projects for beginners. So go ahead and follow these videos and stick with some ROS resources. And how should you learn ROS? I've also talked about this in a step-by-step manner in both of these videos actually. So go ahead and watch those. And meanwhile, if you want a tutorial, I haven't created a tutorial myself, but you can go ahead and watch this really nice, well created tutorial on ROS2 Humble Hawksbill uh, by Robotics Backend. So this is again something that you would be able to find easily on my blog learnroboticsandai.com, and you can go ahead and watch that video. The link is there. Okay, moving on to step number 13. We're already a long way now. Now you would need to define projects based on your own curiosity. Okay, you have built a strong foundation already. You now know ROS, you know machine learning tools, you know OpenCV, you know Gazebo, you know the basic programming, you have the basic programming and mathematics background now. Now it's time to build projects, and to begin with, define projects based on your own curiosity. You should start building projects based on your own interests, because as I said in the beginning, robotics can be challenging. It is interdisciplinary and it involves working with a lot of different domains. So make sure to choose the kind of projects that you really enjoy working with, because if you choose a project because somebody else told you to do that, or if this is a project that everyone else is doing it, it's the most commonly available project, you know there's plenty of resources for this project, plenty of tutorials online. um, you can do that, and that is a start, of course. But if you want to really stick with robotics, make sure and really also identify which domain in robotics you want to go into. Make sure to start with the kind of projects that you find fascinating. And you might be wrong. You might choose a project that you might think that, hey, this would be interesting. And once you start building it, you would say that, hey, maybe this is not the kind of project that I want to do. And you can switch projects, but make sure to start with creating a list of projects that you find really interesting. And how would you do that? You can watch my video titled Leverage Your Curiosity to Learn Robotics, and there I have talked about the reasons why you should follow a curiosity driven framework as the first step to start building projects, and how you can specifically do that in a step by step manner. Like, what are the how many what is the number of projects that you should create in your list, how you should shortlist a project based on feasibility and interest and so on. So watch this video. This is a pretty short video. Let's move on to step number 14. We're almost done. Now you would need to work on projects in different domains. So now once you define some projects based on your own curiosity, and maybe you also started doing those projects, now you need to work on projects in different domains. Because if you choose some projects based on your own curiosity, you might still be missing out on some other different domains in robotics, because you're not familiar with all of the different domains in robotics and AI. So to uh, summarize all different domains in robotics and AI, I have talked about top or major subfields in robotics and AI. Go ahead and watch that video. But to summarize, for robotics software engineering, it's simply put: perception, um, control, learning, and planning. Perception, planning, learning, and control. These are the four key areas or key profiles even for robotic software engineering. If you look at the job profiles, you would see that the positions would say hiring someone for robotic software engineering, perception. So that would be more computer vision and ML side of things. It could be robotic software engineer, control. It could be robotic software engineer, machine learning, specifically robotic software engineering, motion planning, or it could also be task planning. And essentially within planning there's a lot of different realms that you can go into, but these are the broad categories. So make sure to do at least one mini project in all of these domains. Now I have actually created a lot of project videos. So these are some best machine learning projects for beginners. This is on the on my YouTube channel, and also on the website learnroboticsandai.com. Let me actually quickly walk you through where you can really find these project lists. So there are two places you can find it. Of course, on my YouTube channel, I would not uh, uh, scroll through the YouTube channel right now. I would just show you the project list. So this is the current article or blog that goes along with this YouTube video, and these are top 10 machine learning projects for beginners, 10 computer vision projects for beginners, 10 ROS projects for beginners. And actually I would be creating more project lists in the future. So computer vision projects for beginners, and now you can see here, this is from LinkedIn. So if you follow me on LinkedIn, you'd be able to see that I share lots of project lists. These are the lists that I would eventually compile in the form of a detailed blog article on the website as I get time. So meanwhile, you can follow these lists on LinkedIn. So this is one, and then I've also shared some navigation related projects. So here are 10 robot navigation projects for beginners. This is a complete list that you can find. And eventually I'll also create some uh, links for each of these projects, like resources, GitHub repositories that you can follow. So this is now robot perception projects for beginners, and I would probably be creating more projects. So project lists. So here are 10 control projects for beginners. So these are projects that are essentially designed to allow you to really get exposure to all of these different subdomains in robotics software engineering, or allow you to explore and navigate through different robotic software engineering roles, and you can follow and take one project in each of these different resources. And again, as I say, these lists will be, first of all, compiled in the form of blog articles on the website learnroboticsandai.com, and secondly, I'll be creating more project lists in different subdomains of robotics, and even for different applications of robotics. For example, agricultural robotics projects, or humanoid robots projects, or robot manipulator related projects, and so on. So yeah, stay tuned with these. Now the next step is to define your niche. Now by this stage, what you should expect to have done is that you should have done and created uh, 4 or 5 different mini projects, not huge projects, in different domains of robotics and AI: perception, planning, navigation, control, and so on. And a few projects, let's say 2 or 3 projects, based on your own curiosity. And again, all of these projects are supposed to be mini projects that would last 2 months, 2 weeks to 1 month, or if you have time, you can even spend more. But these are mini projects to really give you an idea of what your interests are. And all of these steps till now have been designed to really allow you to define your niche and build a foundational understanding of basic robotics tools and frameworks. So after getting this exposure, make sure to spend some time really defining your niche. You can do that by following this Ikigai framework, and you can essentially look at you would need to make an analysis of what your strengths and values are, and what are the key technology stack that you like working with, what is the impact that you want to have, and what are the job opportunities. So all of these things, and you can watch a few videos. I'm referencing some of these videos. I don't have time to explain in detail why you need to define your niche and how you can specifically do that within this video. I've already talked about these things in a lot of detail in some other videos. So first of all, watch this video titled "Why You Need to Define Your Niche in Robotics." This is a pretty short video. And here's another idea on how to define niche. You have to essentially choose the kind of tools and frameworks that you like working with, the kind of environment that brings you into a flow state. That means that makes you lose sense of time, and your skills and challenge of the task should be in alignment. So again, not going into too much detail, I have actually talked about this in a lot of detail in the video titled "The Ultimate Robotics Career Guide." So go ahead and watch this video, and you can skip the video and go to the part where I talk in detail about niche, or you can even watch the entire video. I highly recommend this. This is going to be a useful video for you. All right. So step number 16, are you a robotic software engineer yet, or do you need to do more things? So now you need to do more projects in your chosen niche. Now at this point, probably you are a bit annoyed because I've asked you to do 2 or 3 projects, and based on your own curiosity, to at least 4 or 5 projects based on different domains within robotics. And now I ask you to do more projects. Why do I do that? Because I want you to really have a strong foundation. You need not do tens and twenties of projects in order to bring a strong build a strong profile. But notice that till now the projects that you have done are mini projects, and the goal for doing these projects was essentially to define your niche. And now the projects that you would be doing would be slightly bigger, so you can take up one project, but that might last 2 to 3 months or even 6 months if you really want to take up an ambitious project. But this project would now be within your niche. So for example, if you did um, one project based on your own curiosity, and that was, let's say, a perception or machine learning related project, and then you did 3 or 4 different projects, let's say one in motion planning, one in control, one path planning, task planning, and so on. So you did all of these projects, and now based on these, now you see that all of these projects were interesting, but this project was slightly less interesting. And uh, you come to an understanding that, hey, I want to go in the control side of things. So I want to go for profiles that are called robotic software engineer control. So you're specifically targeting that. Now you would take up one or multiple projects within that niche. So that is why it is extremely important to follow this um, guide in a step-by-step manner. So now you would be able to build robotics projects within your chosen niche. What is step number 17? We're almost at the end now. Now you should be building a portfolio of projects. You have created so many projects for now by now, and you probably are pretty confident about your skills. If you have built at least one or two major projects within your niche and multiple mini projects within different domains, you should be pretty confident that you're really capable of working professionally as a robotics software engineer. And now comes the stage of really making that transition from someone who is just learning, or someone who is aspiring to be a self-taught robotic software engineer, to really someone is uh, who is very close to becoming a professional robotic software engineer. And the way to do that is to, of course, showcase your projects by creating a portfolio of projects. And let me tell you a story of one of my interview experiences. And this is a standard pipeline that I follow for all of my interviews. I have my CV ready, my curriculum vitae, and my uh, and my motivation letter, which you need to probably send when you're applying for jobs. And another thing that I do is I have a presentation that I've created that showcases all of the projects that I have done. And of course, I might not need to show all of my projects to all of the companies that I apply, but I can essentially filter out the projects that I have done that are probably the most suited to the company that I'm applying for. But I essentially just present that, I just give that presentation, showcase my portfolio, and even in face-to-face interviews, I really print out my portfolio and give it to the interviewers, and they're really impressed by that, because that shows initiative, and that just gives a proof that, hey, I'm not just talking about my experience. Of course, you have written it in your CV, but here are details of the projects that I have done. And of course, you probably cannot share, if you probably have done some projects as part of an internship, you cannot share details of all of the projects, but you can give an overall idea that, hey, this was the projects that I worked with, these were the tools that I worked with, and these are the tools that you also require at your company for this specific profile. So that just really gives a concrete proof for why you are an ideal candidate for the position. So make sure to not skip this step. Make sure to create a strong portfolio of projects, and you already have a strong profile, so you just need to organize things. And here is, let's say, I created a post where I talked about my experience and how you can actually what are the advantages of building a portfolio. And here's my portfolio. This is probably not fully updated or optimized, but this is this should give you an idea of what the portfolio of projects should look like. So make sure to create a portfolio of projects, and you can maybe make it even nicer. This is not the final version of the portfolio that I present. So this is step number 17, and now step number 18 is to create a strong CV and prepare for interviews. This is now an easy step, especially if you have built so many projects. You probably have a strong theoretical and practical understanding of robotics, and you have a good foundational background. Now create a CV, and in your CV make sure to highlight your projects and work experiences. You can even have a look at my CV. This is also on my LinkedIn. You can really essentially have a look. Again, this is also not fully optimized. This is, I think, this was last updated last year, but this should give you a sufficient level of understanding of how to create a CV. You can also find a lot of LaTeX templates, or you can use services like Novo Resume. Go ahead and look up novoresume.com. That allows you to create really beautiful and nice CVs and resumes, and with minimal effort. So this should essentially prepare you for jobs. Okay, we have built so many projects. We have built a portfolio of projects. We have prepared for the interviews. And by the way, one small point that I forgot to mention: for interviews, you also need to prepare um, for some of the theoretical prepare answers for some of the theoretical questions related to robotics, machine learning that they might ask. And you can find lists of interview questions for robotics software engineering profiles, or even machine learning or computer vision profiles. Let me know if you want me to prepare a list of such interview questions for you, if this is something that you cannot find easily online. Although I think there are a lot of resources that you can find online. Just type and search top machine learning interview questions, top data science interview questions, top computer vision interview questions, robotics interview questions, and so on. So make sure to prepare those things. There are some basic concepts that you need to have a strong grasp of. Although, to be honest, you might have a strong foundation already if you have built so many projects, but still prepare for those. Um, and how can you find jobs? I also created a LinkedIn post, which again I'll compile on as in the form of a blog article on the website. So uh, this was a really nice job posting from ROSCON 2023. So this is very recent, and this includes a lot of robotics software, lot of robotic software engineering open positions. You may or may not be eligible for some of these. I mean, you can apply for internship roles, but there's also some senior robotics engineering roles that you might not be familiar with, but you can actually get a strong foundation of what are the skills that they require. You see, ROS, Linux, embedded development, all levels. So these are the kind of profiles that they want. Um, and these are also the kind of projects that you should be doing, because you don't want to learn the skills that the companies don't value. Because eventually, what is your goal? Your goal is to work in the industry professionally. You want to have a job. Okay, uh, this was this, and then there's a list of, if you're in Germany, you can benefit from top 10 most cutting edge, benefit from my video title, top 10 most cutting edge German startups at Automatica 2022 that develop AI for robotics. And these are some of the most amazing startups, and I have experience in working as an intern or working student in some of these companies. Uh, but essentially, all of these companies are top notch, and they would allow you to work on really great technology. Micropsy Industries, Agile Robots, Neura Robotics, Magazino, MechMind, Gestalt Robotics, Suits, RoboMind, Artisans, True Physics. But these are not the only robotics companies. Actually, on the website learnroboticsandai.com, I have I also have a more detailed list. So there's more companies there, and I might update the list to have even more companies in the future. But meanwhile, you can watch this video titled Top 10 Robotic Startups in Germany, and you can go ahead and watch and look at that list. Okay. And this is one specific job profile that I copied from Magazino's official website, and they require you, for example, to have both C++ and Python skills and experience in image processing and computer vision and ROS-based systems. So you see that the roadmap or the guide that I have shared is not just a theoretical guide that has no practical ground. It is actually, I have analyzed a lot of robotic software engineering roles in Germany, in US, in India, and in a lot of countries, and I have really distilled down the top skills that are required for these fields to work industry and how industries work. And also I've taken into account my own experience working in companies and research positions. So make sure to follow this guide in a step-by-step manner. This is very important. If you say that, hey, I'll skip learning Git, I wouldn't learn Git, then you would probably have some problems in the future. So even if you build a project, you don't use Git, it would not be an efficient way, because if you learn Git, you can showcase your projects in the form of a portfolio. Your GitHub profile would be updated. You would have lots of commits on your Git GitHub repository, and employers can see that. You can update that in your CV or resume. uh, so again, just make sure to follow this video in a step-by-step manner. Do not skip any section of this video. Just want to uh, repeat this again too, so that it's really clear. Okay, that is it. I hope this video was helpful, and I wish you all the best on your learning journey.